All right, so if you want to run the stress analysis, have your part open, and you click. Well, actually, before you go any further, you got to select the material. So up here, the top left where it says generic, click that. Just scroll up and select ABS plastic. That'll assign. It'll change the shade of your model a little bit, but it'll assign it to be ABS plastic because when you simulate it, it's going to need that. Now, again, the simulation is not going to be perfect because it's going to show a solid. It thinks it's going to be totally solid. When we 3D print it, obviously that's not going to be the case, but it'll show us the weak points and it'll show us how it's going to bend. So now, once you've assigned the plastic, right, you hit stress analysis. There's a couple things you got to do. All right, you got to hit create study over on the left. All right, and that kind of gives you a preview of what's going to happen. Create study. I always just leave it static analysis, hit OK. Now, the thing you have to do is you got to constrain something not to move, all right? And the thing I constrain not to move is the face of this pocket, right? Because that's going to be stuck pretty much up onto that block. So what you do is we have to fix, all right, fix this geometry here because that's the face that's going to be stuck. All right, then hit OK. And if you look at the preview for this, it shows you, like this one here in the preview, that bottom part must be bolted down or something. So that's going to be attached down. The top one's going to have the stress on it. So let's see where the point is. And that it's going to make like red area where the stress is. So if I pin that interface of this, if I fix it, that makes sense because that's what's going to be bolted down to the block. And then we're going to apply a force to this front part. All right, so we fix and constrain that front part. Pin, frictionless, those are other things you can do. And we're going to put a force on this cylinder. Now, the only thing here is for the force. All right, I'm going to click it. And I'm going to try to put it on this, but the problem is, it's going to point in kind of a weird direction on that cylinder, right? I don't know that I can really move it. I have to think, how did I do this before? I think we put a work plane on top of it or something. Oh, that's right, vector components. FX, FY, you can actually make vector components on this, all right? So we're going to do, let's see what I'm going to do a 200-pound force here. All right. It's not letting me. Here, let me start that over. Let me try this again. Okay, so the vector components, I want to say we're going to do FZ. I'm going to get rid of the F. No. I'm going to make the FZ 0. All right, FY, see, but it's not right on the center there. I'm trying to remember how to get it shifted over a little bit. I'll make this negative 100. Hit OK. I wonder if that'll work anyways. It's going to be putting on the front edge there. Let's see how it goes. Let's see if that'll work. So I did the force. All right. Let me double click on that. Again, I changed it to, put in 100 pounds. I changed it to a component, use vector components, because I want to push straight down on it. So it's not pointing the right direction. Just modify that so it is. All right. And you can make it even bigger. You can make it 200 if you want. All right. and that it'll just make it more dramatic. So then you hit simulate up here. All right, simulate. It's ready to run. If you get an error, it's probably because you didn't select the material. Make sure you select the material ABS. So hit run, and it'll run it. No contacts attached to the body. All right, so now let's see what's going on here. All right, it shows the deflection it's making. All right, it's pushing down, and I don't really get any red here, which is kind of good. It looks like those points there are going to be the most stressed parts in these corners here. So there is some red in there. So I don't really have anything obvious to do. Right, 200 pounds. You know, you can go back, right? Hit finish analysis, and you can make the force even. Oops. Go back into the stress analysis. You can go click loads here, and you can get that force. I can make this even crazier, right? I can make it 2,000 pounds if I wanted to, just to really try to overstress it, just to see where it's definitely going to fail. You'll be surprised. It's probably not actually going to change it too much. You know, clearly, if I put 2,000 pounds on this, it's going to demolish it, right? So, look, it barely changed the stress analysis at all. So the main thing you want to look for in this is if you got anything really crazy going on. Like, if you put 200 pounds on it and the sides are like billowing out, then you're definitely going to want to put something across to kind of hold it together. All right. So this design, there's really nothing obvious to be done here. It looks pretty good. It is bowing out a little bit. You guys see that? It's slightly bowing out right here and here. Not too bad though. I'm not going to add anything in there. For this one, I'm just gonna run with it as is. All right, so that's it. It just gives you a basic idea of where the pressure points might be. If it's something really bad, it will, you know, you'll be able to see that. I've seen some do some crazy things, you know.